Hello. So we recently learned how to factor a fourth degree trinomial that were in the form ax squared plus bx plus c. So what we're going to do today is we're going to take this a step further. We're going to solve fourth degree trinomials by factoring that are in this form. Ax squared plus bx plus c equals 0. So let's take a look at this first example. We have a fourth degree trinomial here. You notice it's already in the standard form that we want. And it's in the form ax squared plus bx plus c is equal to 0. And what's nice about this one is our a value is 1. So we can go straight to the factoring part. We don't have to do slip and slide on it. So I'm going to put down the factors. So I'm going to try to factor this. So we're going to put x squared and x squared. So when you take x squared times x squared, you get x to the fourth. So now we're going to look at the last number, negative 15. What we want to do is we want to put factors of negative 15 in these blanks. Well, there's a lot we could choose. We can choose negative 1, 15, negative 15, 1, 3, negative 5, 5, negative 3. So we got a lot of options. So how do we narrow down which option to choose? Well, the middle term. Remember, the middle term is what they need to add to be. So what we're looking for is two numbers that multiply be negative 15 and add be negative 2. So those two numbers would be negative 5 and positive 3. So now we have it factored. So what do you do once you have it factored? And your two factors are equal to 0? Well, you set each of the factors equal to 0 and then solve for x. So we're going to take x squared minus 5, set that equal to 0. Take x squared plus 3, set that equal to 0. And solve these two equations. Let's see what we got going on here. So what do we got? We got two quadratic equations. And both of these quadratic equations only has the quadratic term. It doesn't have the linear term. So that means we can use the square root method to solve these. So on this first one, we would add 5 to both sides of the equation. We end up with x squared is equal to 5. And then I take the square root. I'm using the square root method. You just got to remember, when you use the square root method, you always got to put plus and minus on your answer on the right-hand side here with what you're taking the square root of that number. The square root of x squared is just x. And then the square root of 5 is just the square root of 5. We can't reduce that. So two of my roots for this fourth degree polynomial are positive and negative square root of 5. Now let's find the last two. So on this one, subtract 3 on both sides. You get x squared is equal to negative 3. Take the square root of both sides. These cancel out, you get x. So x is equal to plus or minus the square root of negative 3. But remember, we can't leave a negative under a radical. So we can rewrite the square root of negative 3 as the square root of negative 1 times the square root of 3. So our other two roots are plus or minus I radical 3. So if we look back here, we started with this equation here. X to the fourth minus 2x squared minus 15 is equal to 0. This is a fourth degree, so it should have 4 roots. We have 4 roots down here. We got 2 real roots, and then we got 2 complex roots. So our roots are the square root of 5, negative square root of 5, I radical 3, and negative I radical 3. The degree of the equation tells you how many roots you're going to have. Since it's a fourth degree, we have 4 roots. These first two are real roots. And the last two are complex roots. All right, so let's take a look at another example here. It says find out the roots of the given polynomial. What do we have? A fourth degree, so we got to find 4 roots. And look, it's in that form. It's in the form a x to the 4th plus b x to the 2nd plus c is equal to 0. So we're going to try to do it by factoring. But the a term is not 1 over here. So we're going to use slip and slide. So we're going to get our leading coefficient to be 1. So we're going to slip that 4 to the back, multiply by the negative 27, and we get negative 108. So now we have a leading coefficient of 1. So when I ask myself, what 2 numbers multiply to be negative 108 and add to be positive 3? So we'll put x squared down and x squared. Did you guys find the 2 numbers that multiply to be negative 108 and add to be positive 3? It's positive 12, negative 9. Now in the first example we did, we were done at this step because our original equation had a leading coefficient of 1. But this equation had a leading coefficient of 4, so we're not done. We're using slip and slide, so we're going to slide 4 back into our equation here. And then you got to reduce these fractions. So 12 over 4 reduces down to just 3. 9 over 3 reduces down to 12 over 4 reduces down to 3, right? Right? 9 over 4. Oh, yeah, I should have had 9 over 4. I couldn't figure out what I did wrong. Mrs. Stuckey helped me. Remind me what I did wrong. 9 over 4. There we go. And then 9 over 4 reduces down. Well, can we reduce 9 over 4? No, we can't. So we'll just leave this as 9 over 4. Okay, so normally, if we were just factoring this, we would take that 9 over 4, the denominator of 4, and move it in front of the x squared so we can factor it. But we really don't need to do that since we're trying to solve it. So we can just leave that fraction there. So what we're going to do now is just set both of these factors equal to 0. Set both of the factors equal to 0 and then solve for x. So on the first one, we would subtract 3 from both sides. We get x squared equals negative 3. And then take the square root of both sides. These cancel out. So we get x is equal to plus or minus the square root of negative 3. We just seen that on the first example. That's I radical 3. Now let's solve the other side. So we would add 9/4 to both sides. We get x squared equals 9/4. Take the square root of both sides. These cancel out. We get x is equal to plus or minus. Whenever you take a square root of a fraction, you just want to break it down to 2 square roots. So it's going to be the square root of 9 over the square root of 4. So our other 2 roots are positive and negative 3 over 2. So again, we had a 4th degree equation, and our 4 roots are I radical 3, negative I radical 3, 3 halves, and negative 3 halves. We got 2 real ones and 2 complex ones here. Let's do one more example here. Here's the last one I want to do with you guys. It says find all the roots of the given polynomial equation. Again, it's in the form that we want it to be, ax squared, ax to the fourth, plus bx squared, plus c is equal to 0. But again, our leading coefficient is not 1. So let's get our leading coefficient to be 1 by using slip and slide. So we want to take the 6, slip it to the back, multiply by the last number. 6 times -1 is -6. Now I'm going to ask myself, what two numbers multiply to be -6 and add to be the middle term, which is a 1? This one's a lot easier to figure out in our head than the last one. Multiply be -6, add to be 1. So +3 and -2. And again, we're using slip and slide. So the number we slip to the back, we got to slide that back in. So we're going to divide both of these by 6. Reduce our fractions. So 3 over 6 reduces down to 1/2. 2 over 6 reduces down to 1/3. And then again, you could do this, but you don't have to. If you wanted to, you could put the 2 in front of the x squared. And rewrite that as 2x squared plus 1. And rewrite the other side as 3x squared minus 1. But since we're just solving it, you're actually doing extra work if you do that. It's just creating an extra steps. So I'm just not going to do that. But if I was just factoring it, and I ask you to factor it, then I would want you to do that. But because we're trying to solve it, you don't need to do that. So now, let's take both of these factors, set them equal to 0, and then solve. So this one, we would minus 1/2 on both sides. We get x squared equals -1/2. So now we're going to take the square root of both sides. Square root of both sides. These cancel out. We get x equals plus or minus the square root of -1 over the square root of 2. Well, the square root of -1 is I. So I got plus or minus I over the square root of 2. Now, in algebra, we don't want to leave a square root in the denominator. So what we got to do is we got to get rid of that square root without changing the answer. So since we have the square root of 2 on the bottom, what I'm going to have to do is I'm going to have to multiply by another square root so that I can make the number under my square root a perfect square. So what can you multiply 2 by to get a perfect square? 2. So what I'm going to do is I'm going to multiply the bottom by the square root of 2. Now, if I just multiply the bottom by the square root of 2, I'm changing this answer. So what I'm going to also do is I'm going to multiply the top by the square root of 2. If you think about this, what is the square root of 2 over the square root of 2? That's 1. So you're multiplying this by 1. If you multiply something by 1, you're not changing the answer. So I'm not changing the answer, but what I am doing is I'm getting rid of my radical, my denominator. This is called rationalizing the denominator. So on top, we're going to have I times the square root of 2, which is just I square root of 2. And on the bottom, we're going to have the square root of 2 times the square root of 2, which is the square root of 4. And like I said, the answer is not simplified if you have a square root in your denominator. Well, we have the square root of 4, so it's not simplified. What is the square root of 4? 2. So this is my final root for this quadratic equation we're solving. I square root of 2 over 2. There's 2 of the roots. Now we got to find the last 2. So to do that, we're going to go back up here and solve this quadratic equation. So we're going to add 1/3 to both sides. We get x squared is equal to 1/3. Take the square root of both sides. Let's cancel cancel out. So you get x equals plus or minus the square root of 1 over the square root of 3. What's the square root of 1? Square root of 1 is 1. So we got x equals plus or minus 1 over the square root of 3. And just like on the other one that we did, we ended up with a square root in our denominator. We can't have that. So we're going to have to multiply the square root of 3 by another square root to make it a perfect square. So the easiest one to use would be just the square root of 3. So again, we're going to multiply the top and bottom by the square root of 3. So we're really only multiplying by 1. We're not changing the answer. So we get x equals plus or minus 1 times the square root of 3, which is just the square root of 3. And then on the bottom, square root of 3 times the square root of 3 would be square root of 9. And then the square root of 9 can be reduced. So we get x equals plus or minus the square root of 3 over 3. So again, we have 4 solutions. It looks like we only have 2, but that plus and minus sign, remember, means that it's 2 roots there. So our 4 roots are I square root of 2 over 2, negative I square root of 2 over 2, square root of 3 over 3, and negative square root of